Hey everybody, how's it going? Thanks for having me. And I'm going to talk about putting humans back into the loop with automation, with artificial intelligence in a broad term, in that it includes everything from good old-fashioned AI to machine learning to deep neural networks, right? And this is kind of what I want to talk about, but I really want to motivate this with kind of the sense of why we'd want to do this. And so I'm going to start a bit about what I do. So yeah, as Anna mentioned, I'm a professor in music and computer science at Stanford, and I do computer music. That's me in my office. And I've been at Stanford now for 12 years, almost 12 years. And I build things, I design things. I design things like programming languages, toys, tools, games, social experiences in the service of music with technology. That is what I do. I work a lot with code. I think code, above anything else, is really, that's my craft. That's my art. I build things with that. And as Anna mentioned, I work with the laptop orchestra. This is the Stanford Laptop Orchestra, or SLORC. And then I deal with mobile devices starting about, 12 years ago. And I co-founded a company, and that's Smule. It's still going, we have like 200 people now at Smule. I stepped down from the company 5 or 6 years ago, but I still go back and say hi. This is still my baby, right? And so this is kind of the context I'm coming from, but I want to take you back even further in time. I want to rewind 40 years, and I was born here in Beijing, right? In fact, I grew up right there in the 7th floor of this building. I grew up with my grandparents. Grandma, by the way, just turned 100 years old back in April. So, oh, well, go grandma. Yes, I'll pass along your congratulations to her. I was just in Beijing celebrating this with her. My parents were working in other parts of the country. I grew up with my grandfather and grandmother. And, Beijing has gotten a little bit more polluted, a little bit more congested since the time when I grew up there. But it's still my hometown. And so that's kind of where I grew up. And I grew up with comic books, video games. I played a lot of them. Also, I spent a lot of time watching other people play video games. I think this actually shapes the sensibility I have in making things. I think the things we make ought to be interesting. They ought to engage us and in a way, be artful. So I still play video games. I went to undergrad and got a degree in computer science. This was 20 years ago. Why did I do that? Well, 20 years ago, you majored in computer science for kind of the same reason you major in any other thing, because it seemed interesting, because it seems fun. Back then, it was not an automatic kind of like, pathway to getting hired. Back then, this is what you do if you're interested in building things and making things and understanding how computers worked. And I learned things from my professors from, hey, in software, as in life, there are 2 good answers to almost any question. I don't know, and it depends, right? These actually remain good questions if you are doing any kind of technology and shaping of technology, or if you're trying to be like a good person in life. There's a certain situational quality to the way we make decisions. I went to grad school in computer science and learned about computer music, which is my special area. That's my advisor, Perry Cook. He taught me everything I know about generating sounds and making music with computers and also creating instruments out of computers. My dissertation was a programming language called Chuck, and I'm going to give you a demo of Chuck right now. So this is the stuff, this is what I do, right? So let's see, here's some code. I'm actually going to start over and rewrite this code. Get rid of some of this clutter in the back. Okay, so let's create a sine oscillator. We'll call it foo. We'll chuck it to the DAC. We'll say the frequency of foo is 440 hertz, and we'll let time advance for 2 seconds. Now, if I do that and run the program, okay, we have a sine wave of 440 hertz for 2 seconds, right? Now, I can take this, I'm going to copy and paste this and say this is half of it and this is double it. So we're really going up successive octaves in pitch. Now we're going to put this into an infinite loop. And we're going to automate this in a very simple manner. Okay, this thing's going to go on for a long time. And I'm going to go ahead and just stop this and just take one of these. And we're going to generate a random number between 30 and 1,000, set that as a frequency. Every half a second, every 200 milliseconds, every 100 milliseconds. I want to pause at this point and note that we have just created computer music. This is the sound that old computers in like sci-fi movies are supposed to make when they're thinking really hard, right? And every 10 milliseconds, every 1 millisecond. This is all still just one sine wave, but we really are controlling it at vastly different time scales. And this is through design of a programming language as a tool. This is a tool for you not only to generate sound, but for you to think about how to generate sound. That's what tools do, right? Tools are things that really give you a conceptual model of how you can achieve a certain task. That is what a tool is in its broadest sense of the word. And a programming language, by design, is a certain kind of tool. And every programming language is its own tool because they do things in a different way and get you to think about things in a different way. Now, that's a tool. Now, you know, in Chuck, you can actually go up. So you can change frequency every minute, hour, day, week. You can also say 52 weeks is my notion of a year. And every 1,000 years, there will be a new random frequency. In 1,000 years, the frequency may change, right? That's kind of the time scale you're working with in Chuck. So we're not going to wait until that happens. Instead, I'm going to continue with my talk. Now, Chuck is something that that actually gets used in pretty much everything else I do because I'm programming with sound. And 3 years ago, I started writing this book called Artful Design. I wanted to put all these things, like that, the way of thinking about design, this way of thinking, of designing tools for humans. I wanted to put that down into a book. And I started writing a book about computer music, but then it became a book not about computer music or art, but a book about how we as humans shape technology and how that technology that we create come back to shape us. That became the subject of this book. So it became a meditation on design as a humanistic, artistic, and social act of engineering. The shaping of technology, that's Artful Design. And the format of the book kind of got out of control because I started by writing a normal book, a conventional book, then it became a comic book. And then the whole book became a comic book. So what we ended up with is a 488-page photo comic book with over 1,600 photos. And by the way, like after this talk, I'm going to be hanging out by where you get coffee, which I think is a good thing to pair with design and coding. And I have books here, so come and talk to me, and I'll sign a book if you want to buy a book. So that's Artful Design, but much more on this. So if we think about this topic of artful design, and I'm not talking about making art with computers, I'm talking about designing everything, the tools we have in life, in an artful manner, then the questions kind of become, what is the nature of that design? What does it mean to do it well? And what does it mean to do it ethically? Like, these are the questions I think that confront us, all of us, when we think about technology, when we think about AI, machine learning, deep learning, robotics, genetics, security. And these are all things that I think we cannot quite escape, like these questions, as we shape technology. So I'm going to give you a few examples of this. First one is actually just the craft of design, right? This is something I designed now 11 years ago for the phone. This is Ocarina. So I'm going to give you just a quick demo of Ocarina. It's an app on my phone, and you play it by blowing into the phone. So multi-touch. Oh, well, thank you very much. So yeah, you control pitch with multi-touch. You play it, you articulate it by blowing to the microphone at the bottom of this phone. Inside the phone is actually a Chuck program written in the language that we just saw earlier that's generating the sound and mapping its frequency, its vibrato, to the input, the physical interaction you have with this. And you can map vibrato to the tilt of the phone. So in a way, well, this is an instrument. It's also a toy, but it's also a tool. It's something you can learn, that you can get better at, that does something that you wanted to do. Now, a closer look at Ocarina, the design. This is what it looks like. It's pretty minimal. You just see kind of the functional parts of the ocarina. And all the graphics respond to your interaction. Right? I want the scene to feel organic and alive. The quadruplet of circles going down the middle here. Now that's hinting as to how to play the next note. It's kind of like Rock Band or Guitar Hero, but it's like Ocarina Hero. And in this case, but unlike Guitar Hero and Rock Band, you're actually generating the sound right on the device, and no two playing of the same song is ever quite the same. And now that's one part of Ocarina. Now there's a second dimension to the same app. In Ocarina, you can listen to other people blow into their phones around the world. There's a globe visualization in which you can see, oh, hey, there's someone playing O Shenandoah from the East Coast. Who is that? Well, it's anonymous. This person didn't give themselves a name, and it doesn't really matter. Like, I think this is a kind of a strange social network. First of all, it's one based on music. Secondly, it's an anonymous social network where identity does not matter as much. It's kind of what music you're playing and where you're doing it from. Like, who are these people? I don't know. But the app, in a way, was designed not to tell you, to make you feel a sense of connection to an anonymous humanity out there. Oh, Shannon, this is Susana, coming from Indonesia, right? So this is designed then as a social experience, one that gets you to feel a sense of connection with others, not unlike ourselves. They're the same interaction we're doing. And this is a review left for Ocarina on iTunes. This is my piece on Earth. I am currently deployed in Iraq. This is from 2009. And hell on Earth is an everyday occurrence. The few nights I may have off, I'm deeply engaged in this app. The globe feature that lets you hear everybody else in the world playing is the most calming art I've ever been introduced to. It brings the entire world together without politics or war. It is the exact opposite of my life. Right? Now, as a designer, as a shaper of any technology, you know how good it feels when someone uses anything you've built. But this, for us, was a different level. This is something that we did not expect. And because I think, Ocarina did not in any way physically or practically help this individual. It did not pluck this individual out of the hell they found themselves in. But, like art, I think it provided a moment of peace to help them transcend the hell. Much like, think about your favorite song. I think the music and the movies and the art that we love, that matter to us, right? They're the things that help us really make sense of life, in the midst of life, right? So this is all to say good design is something that enables us, like a tool would. But great design, I say, is something that strives to understand us, to afford us this kind of understanding about ourselves, right? Again, your favorite song, right? If you think about your favorite song, now I would imagine we all have maybe different songs that are our favorite song, but I might also offer that maybe for each of us, our favorite song or favorite songs offer an understanding of who we are, of who you are, now or at some point earlier in your life, or that the song tells you something about you in relationship to another person in your life. Same with movies, same with anything that you might call art. That, I think, is great art. It's not when you've understood how great the art is. Great art is when you feel like the art has understood you. I think that is great art. And I would add, great art isn't just found in museums, but found really in the midst of life, if we care to look for it. So that, in a way, is kind of what it means for me to design artfully, but now we turn our attention to automation, right? Specifically, kind of this notion of artificial intelligence as a broad kind of umbrella term for everything from good old-fashioned AI expert systems back many decades ago to now machine learning, deep learning, robotics, all of these things of thinking about how it's not us programming machines, it's us programming machines that can, in fact, kind of shape themselves, especially given large amounts of data. And also this idea of like automation in general. What does it mean to design automation and artificial intelligence well and to do it artfully? What is it that we're really getting at? Well, from Artful Design, I have this principle in the book. And the book has like over 100 principles. This is one that I think specifically applies to automation and to AI. The first part of the principle says that which can be automated should be. All right, think about that first, all right? Now, the second part, though, is an exception. It's to say that which can be automated should be, except for that which can not be meaningfully automated. Well, those things should not be. That's it, right? This is to say we're seeking a kind of balance in the way we actually employ automation between the extremes of excess, that's too much, and the realm of deficiency, that's too little, right? What is that balance that's in the middle? And how do we design? And is that not kind of the golden goal of design, is to find the perfect balance, the exquisite balance between extremes, right? So I'm going to give you an example of perhaps, well, this is very automation. There's a lot of automation. And I don't know if it's too much, but you be the judge of that. We have the notion of a big red button. Now, this is an AI system that you just press the button and give it some input, and it might give you some output. You don't know and you don't need to know what goes on inside the inner workings of this. And certainly we see this, for example, in art, in the realms of style transfer. We've all seen things like this. You take Stanford, you take Starry Night, you put them through a deep neural network. You press the big red button, and what comes out is Stanford in the style of Starry Night, right? That's an example of style transfer. And certainly, famously, deep art has done this. Starry Night with a cat. Big red button. Someone's face with fruit. Big red button. Face with mat. Big red button. Doge with macaroni. Big red button. And this one, can you guess from what famous painting the style was transferred from? Oh yes, I see the gesture. It is the scream of nature. Edvard Munch. Now, we should pause here and consider what has been transferred. Well, something about the style undeniably has been transferred, and transferred exquisitely. And this is something that is, you can't really program this, not directly. It is so, how do you even, because we can't even talk about what style even means in the context of, say, painting. That's a really, really difficult notion to capture. However, this is what machine learning is, deep learning is so good at. It's capturing the things that we can't directly articulate. In fact, I would say, in terms of this kind of in nuance, machine learning, deep learning specifically, we've never had a tool that's more powerful at doing that than we do now. Like, no point in human history have had a tool that's so good at capturing, at different hierarchies, something of the style. But now let me ask, what is lost in the transfer? What did not get transferred? I think that, is the question, right? And, if I look at this, I'm like, wow, this looks like some happy couple on vacation, unaware that, well, if you put this side by side, this becomes a new kind of art by juxtaposition. This happy, blissful couple is unaware of this poor fellow here having a moment of crisis, of existential crisis, and perhaps, horrified at the condition of human existence. You don't really get that here. Instead, these people seem rather content that, in fact, there's like a river of lava behind them, I guess, and they're under this crimson sky, but they seem oblivious to it. So what I'm saying is, well, in the transfer, we have to know what we gain and also what we lose, and to know that helps us think about what is the right amount and when do we want to do these things and in what way, right? Here's a tweet. This is one of the senior editors at Wired magazine, who tweeted once, "The scary AI future is not Terminator, when the AIs kill us or take our jobs. The scary future is one where AIs run all the bureaucracies, they can't explain their decisions, and there is no appeal to humans." Right? That is truly scary. Like, yes, it's obvious we don't want to be killed, maimed by our own creations. That's rather Frankensteinian. But this is a more subtle kind of a situation, of a dire situation, where we kind of lose the kind of agency we actually want. Just because we can automate it does not mean it's meaningful to do so in all cases. And where is the balance? So in comes I think what I would call, many others would call human in the loop. This is a way of designing, of thinking about design that I think is broadly applicable to any AI system. At least it's worth asking the question, right? And for this, I'm going to present a few case studies. One is from Rebecca Fiebrink, who's a professor at Goldsmiths University. And she made a tool called Wekinator, based on, it's actually a neural network that learns and works with you to craft basically an instrument. And in this case, she's combining machine learning with human-computer interaction and music, human in loop. So let me try to play a bit from the result.
Set up to recognize 3 different positions: me standing in front of the camera, me standing to the side of the camera, and my hand in front of the camera. For each position, my drum machine is going to play a different combination of drums. By the way, the drum code is written using Chuck, so if you know a little bit of Chuck, you might recognize the sounds.
Thanks, Rebecca.
And there we go, all controlled using the webcam on my computer.
Okay, how did that work? What we did not see here was how she trained the system. The system was trained not in like one fell swoop, but over actually in like 2 or 3 minutes, and but iteratively, where there's a machine learning aspect that at different stages gave feedback to the human and asking it in essence, hey, how do you like what we got so far? And the humans iteratively would provide a kind of interaction, a curation through interaction to say, well, hey, that's close. Let me give you a better example of what I want, or a refined example. So this is a refinement loop of using, this is actually not a deep neural network. This is just a single layer neural network, just machine learning, right? But with that, she's able to provide additional examples, and the system becomes more and more nuanced until it's to her satisfaction. That is rather remarkable, because this actually uses machine learning, but also human interaction. And this really, if you're looking for a research field to look more into, it's all there. It's actually in the realm of interactive machine learning. That's one of the names it goes by in the research field. And I'm going to give you one more. This is by my grad student from a decade ago, and he was doing this stuff quite a few years ago before anyone else. And this is really, what he's trying to do is, the problem he's trying to solve is one of source separation. Right? You get a piece of music, let's say a song. And from the song, you want to separate out all the different instruments and voices. That, by the way, is a really hard problem, I can tell you that. But he was using signal processing, machine learning, but also user interaction to do this in kind of a really exquisite balance.
Drum beat and try to extract a drum layer and a bass layer out of the single recording. I'll use the color yellow to select the drums and the color blue to select the bass. Before that, let's take a listen.
So that's the mixture. That's what you're trying to separate.
Now I'll do a little selecting and extract.
So know what he's doing. This is a UI that he's built, right? And he's basically painting by example.
Separated drums and then the bass.
So this is initial extraction. Close, but it's got a lot of artifacts in it. What does he do? Oh, here's the bass layer. It's okay, but it's still got some drums in it.
The drums and the bass separately, the results aren't perfect. No problem, we can correct for errors in the separated layers by further drawing on the outputs to refine the separation. This will take a little bit of time, but in the end, the results will be worth it.
So he's giving him more and more examples. And this is only achievable through this interface.
Final result.
Better. Much better separation.
Even more awesome.
Okay, so that's a basic idea, right? This is a task you could assign to a big red button and be like, do it. And if you don't like the result, what can you do? Well, you got to go back and try to tune the system, hope for the best, that it's going to improve in some way. But in improving some things, other things kind of get messed up. Now, this way isn't like a magic bullet, but what it's doing is providing a tool for you as a human to kind of put your curation, your preferences, and your judgment into the system while still really taking advantage of the machine learning that is happening. Like, this stuff is not possible right now by just sheer programming, and it's not possible like by hand. You need automation. But this is a kind of like really iterative, human interactive iteration that in a way achieves this result. And the year he did this, this blew away the competition. This actually won 2/3 of the benchmarks at the conference that year for by far being the highest quality separation. And and Nick had to modify the machine learning algorithm just a bit to be amenable to this kind of user interaction, but that was part of the design, right? So that's the principle, I think, here, is that what we're after, perhaps, with AI is not always some oracle, right? And what I mean by that, well, oracle, what's an oracle? Well, I'm thinking about the Greek oracle at Delphi. The oracle it's the fortune teller. You give it some question, a query, a problem, and it comes back, spits out the right answer. You don't know how it got to that answer. You just get the answer. In contrast, a tool, which we've been looking at throughout this talk. Remember my definition for a tool. A tool is something that you can learn. It's a craft, something you can get better at, and something with which you can exercise your agency and your preferences and your judgment, but in conjunction to what the tool is really good at doing. Right? We can't do everything by hand. The computer is a tool. The screwdriver is a tool. A programming language is a tool. And can AI be a tool rather than kind of this magical oracle-like thing that gives us just the right answers without telling us how? Because at the end of the day, maybe we still value the how. So all of this is to say, I think tomorrow's engineer, and this is me speaking as a professor, trying to help students really gain the broadest perspective possible about things like artificial intelligence, how we shape this technology. I think that engineer, that designer, I think for all of us, we need to be more than specialists. We need to be a kind of technological artist, a moral, ethical inventor, and a system designer that can design systems that we're aware and can reflect on the context of its use. That's, I think, what we need to be. Now, in higher ed, by the way, we talk about these different shaped students, right? There's the I-shaped student, which is like a student with just depth. We don't want that. That's like, we want them to have something more like a T-shape, where there's like a depth and a breadth of knowledge, right? I'm going to tell you about the PieShaped student, or the PieShaped individual. On one leg is disciplinary expertise, like computer science. AI, machine learning can go down here. Domain expertise. Having some expertise in a domain of where you're applying this to. For me, it was music, but for someone else, it could be public health or security, right? But then this thing is an aesthetic lens. It's a philosophical, artistic, moral lens that gives broader meaning and context in bridging the two legs. And in a way, for me, this is why engineering, technology, the arts, the humanities, and social sciences cannot be separated. These are not things to even put together as so much as things that should never have been taken apart, right? And for a good designer, an artful designer of AI, you would hope that's a person who has all of our interests, the public good interest in mind. And to do that, I think they need to think broadly as possible about the consequences, but also the potential benefits of what they design and what we design, right? So I've been trying to teach this in a class called Design That Understands Us. I'll just give you one example of a final project the students did. Now, they didn't have to build this. They just have to design, kind of put a speculative design on this. One student did basically a machine learning project that converts legal document into more of a human-readable form. Like, who wouldn't want that, right? But what makes this human-in-the-loop kind of design is actually a slider they've designed at the bottom. Now, this is not a big red button because the slider, you can actually select the amount of jargonness you want the output to be. So on one hand, you just get back the original legal document, and it's all its jargon glory. On the other side, you get something that's more resembling very plain English, and in the middle, there's every gradient of what you want it to be. Now, this becomes, instead of an oracle, a tool. And isn't that interesting? So with this, I'm saying with any artificial intelligence system that we care to design, there's always a moment that I think we get to reflect before we even build the thing, before we even ask how's this going to work and how are we going to actually situate this in the context of a company, of a product. I think the question is how can we make this better by artfully putting human into the loop, right? One final example. This is a question asked by a colleague at Stanford. She asked me once, hey, good, do you think we'll ever have robot musicians? I'm like, you mean that as good as humans? She said, yeah, that's what I mean. And I gave her this answer, which I'd never given anyone before that, which is like, yeah, you know, I think we'll have true robot musicians the day we have true robot philosophers. She's a philosophy professor, so I thought this is an appropriate answer. But this is also kind of to say that we actually don't have the answers. I don't have a way to answer this question of what it means to be a robot musician. What does it mean for machines to generate art? They might be interesting, certainly interesting, but what does it mean? And the meaning thing at the end of the day is something that for all of us as humans matters. Like it's the meaning in there. Anyway, I think she liked this answer. She immediately said, oh, that's because of implied machines will have understood something more subtle about being human. And I think that's it. I think this is what, AI isn't here to really offer us some magic bullet to everything. AI is, I think, a new tool with which we can do things better, but in reflection to kind of what we really want as human beings. And I would argue that often is the case, just like, you know, eating out at a restaurant is great, but I don't know, I would imagine some of you enjoy cooking for the sheer pleasure, for the sheer meaning of actually taking the raw ingredients and building something of your own design, right? That's, I think, the same kind of analogy I think can be applied to automation and AI. And at the end of the day, I think this is the question. This is an aesthetic question, it's an ethical question, I think it's a business question. It's a question at every level. It's how do we want to actually live with the things we build? How do we want to live with our technologies? How do we want to live with ourselves, right? So that is the question I would like to leave you with, is this question. Especially when you can apply this question, I think, to every single technology we care to think about. And today, especially AI, machine learning, and really any technology. So in the end, I would say, yeah, I performed a structured brain dump of like my brain, for better or for worse, into comic book form, right? All of this is in the book. And the book really, at the end, notes that what we make makes us. And I think tries to get this question of like, are the things we're building actually helping us to be happy, to flourish as human beings? Or is it just that we want more? And is this actually, well, is this actually where we want to be? So it poses all these questions. In any case, this is what I have to say today. And I want to thank all of you for listening. Come and visit me by the coffee place, and we can talk more artful design. Thank you very much.